Friends, now we will see one university question on calculation of deflection by conjugate method. This is for JNTU for the year 2015. It is a simply supported beam of length 5 meters carries a point load of 2.5 kilonewton at a distance of 1 meter from each end. AB is the simply supported beam. Total span is 5 meters. At a distance of 1 meter from A, there is a point load of 2.25 kilonewton, and there is another point load of 25 kilonewton from point B. There are 2 point loads of 25 kilonewton at a distance of 1 meter from each end. If E is equal to 2 into 10 power 5 Newton per millimeter square and I is equal to 1 into 10 power 8 millimeter power 4 for the beam, then using conjugate beam method, determine the slope at each end A and B and under each load, that is point C and D. 2. Deflection under each load and also at center. So we have to calculate slope at A and B, slope at C and D. We have to calculate the deflection at C and D and also deflection at point E, which is the midpoint of the total beam AB. These are the dimensions given. By virtue of the symmetry, the value of reaction RA is 25 kilonewton and value of RB is also 25 kilonewton. There are 2 point loads, each of magnitude 25 kilonewton. And we have to draw the conjugate beam method. Sorry, we have to draw the conjugate beam for the given beam. AB is the given beam. A dash, B dash is the conjugate beam. That is corresponding beam. Conjugate beam means corresponding beam. A dash, B dash. What about the end conditions? Simply supported support will remain as simply supported. A is simply supported. Therefore, A dash is also simply supported. B is simply supported. B dash is also simply supported. This is about the end conditions. AB is the simply supported beam, given beam. A dash, B dash is the simply supported beam, conjugate beam. Now, what about the loading diagram? Bending moment diagram in the given beam will become the loading diagram for the conjugate beam 1 by EI times. Now, here, what is the bending moment at A? It is equal to 0 because arm distance is equal to 0. And it varies linearly from point A to C. It is 25 into 1. That is the bending moment at point C. Similarly, bending moment at point B is equal to 25 into 1. From here, the bending at point B, the bending moment is 0. It varies linearly from B to D, and at D, the bending moment is 25 kilonewton meter. So here dash to C dash, the bending moment is 25 kilonewton meter into 1 by EI. Similarly, here also the bending moment ordinate is 25 kilonewton. Therefore, the ordinate is of the loading diagram is 1 by EI times 25 kilonewton meter. Bending moment 1 by EI times the bending moment diagram will be the loading diagram for the conjugate beam. So this loading diagram is nothing but the bending moment in the given beam into 1 by EI times. This is the conjugate beam. Now, how to calculate the slope? Slope at any point of the given beam will be equal to shear force at the respective location of the conjugate beam. We have to calculate slope at A, theta A. Now, theta A in the given beam AB is equal to shear force at A dash of the conjugate beam. That is the conjugate beam. Theta A, the slope at A is equal to shear force at the respective point of the conjugate beam. Theta A is equal to shear force at A. Now, what is the shear force in conjugate beam? The shear force in conjugate beam at A, the reaction RA dash will be the shear force in the conjugate beam. Now, RA dash is given by 1 by EI times. This EI is common. Take it outside into area of this triangle. 1 by 2 into 1 into 25. We will calculate the total load. Total load means here you have one triangle, here you have another triangle, 2 times. So that is 2 times. 1 by 2 into 1 into 25 into 2 triangles plus 1 rectangle, that is 25 into 3. This is the total load into 1 by 2 into 1 by EI, which is the common factor. Therefore, RA dash is equal to 50 by EI. Loading diagram for the conjugate beam is equal to the bending moment diagram of the given beam into 1 by EI. 1 by EI is common, take it outside. Loading diagram means this area of these 2 triangles plus 1 rectangle, 2 triangles. Therefore, this 2 area of 1 triangle 1 by 2 into 1 into 25, this ordinate, plus area of the rectangle 25 into 3. This total load divided by 2 is equal to the reaction at A dash or A dash, and that is also equal to the reaction at B dash or B dash. Each one of them is equal to 50 by EI. Now theta A of the given beam is the slope in the given beam. Theta A is equal to FA dash. That is the shear force at A dash is equal to 50 by EI. 50 E into I. This E value and I value should be used consistently. E is given as 2 into 10 power 5 Newton per millimeter square. That is equal to 2 into 10 power 8 kilonewton per meter square. E is converted into kilonewton per meter square from Newton per millimeter square because the loadings are in kilonewton and the dimensions are in meter. Therefore, E value is converted into kilonewton per meter square so that the units are consistent. Similarly, I value is given in millimeter power 4, 1 into 10 power 8 millimeter power 4, that is equal to 1 into 10 power minus 4 millimeter power 4. The dimensions are all in meters, the span. So we have to make the units consistent. I is converted into meter power 4, E is converted into kilonewton per meter square. So 50 by EI. E value you substitute here, I value you substitute here. This is equal to 0.0025 radians. If you want to get it in degree, multiply it by 180 and divide it by 5. Then you will get 0.143 degree. This is theta A. And what about the other slope, theta B? That is equal to theta A by virtue of the symmetry. Then it is over. Now we will come to theta C. Because they are asking us to calculate the slope at the each load. Slope has to be calculated at C as well as D. Slope at C is equal to the shear force at C dash. That is the formula. Slope in the given beam is equal to shear force in the conjugate beam. So what is the shear force? Shear force is one shear is due to RA and the other shear is due to this triangular load. RA minus this triangular load will be the shear force at C dash, and that will be equal to theta C, and that is what has been calculated. 1 by EI, it is common, RA 50 kilonewton minus this effect of this triangular load. This is upward, this is downward, 1 by 2 into 1 into 25. So this comes to 37.5 divided by EI, that is equal to 0.0019 radian into 180 by pi will come to 0.107 degrees. This is the slope at C and D of the given beam, which is nothing but the shear force in the conjugate beam. Shear force is due to RA dash minus this triangular load. Now we have to calculate the deflection. The deflection in the given beam is equal to bending moment in the conjugate beam. That is the formula. Deflection is equal to bending moment. Please note, slope is equal to shear force. Deflection is equal to bending moment. So slope of the given beam is equal to shear force in the conjugate beam. Deflection in the given beam is equal to bending moment in the conjugate beam. Now let us calculate the bending moment at, let us calculate the deflection at point C and D. That is, we have to calculate the deflection under the load, that is at C and D. So deflection at C is equal to bending moment at C dash. This is the given beam, this is the conjugate beam. Deflection at C is equal to bending moment at C dash. What is the bending moment at C dash? We have one bending moment due to this reaction RA dash and another bending moment due to this downward load, that is triangular load. This is acting at a distance of 1/3 of its base, that is 1/3 meter, that is 0.33 meter from here. So these two bending moments should be considered for getting the value of the bending moment at C dash, which will be equal to the deflection at C. We will see here. 1/A, common factor, take it out. Bending moment due to RA, that is 50 into 1 meter. 50 into 1 meter. Now, what about this triangular load? Minus, this RA is upward. This triangular load is downward. 1/2 into 1 width of the triangle into 25, the bending moment ordinate. This is 25, that is the area, into arm distance. Arm distance is 1/3, 1/3 of the base. This is 1 meter, therefore 1/3. This is the bending moment at C dash, that is equal to the deflection at C of the given beam. Upon simplification, we are getting this as 0.00229 meter, that is 2.29 millimeter. This is the deflection at C as well as deflection at D. Now, deflection at E, E is the midpoint of the given beam, E. So, deflection at E is equal to bending moment at E dash. E dash is for the conjugate beam. Deflection at E is equal to bending moment at E dash. When you call it bending moment at E dash, it has three components. One is due to RA. This is acting upward. The other one is the triangular load. This is the triangular load. Then you have half of this rectangle. 25 by EI is the ordinate and 1.5 meter is the width. This is the half of this rectangle. What about the arm distance? For RA, the arm distance is equal to 1 meter plus CE. CE is equal to 1.5 meter because this distance is 3 meter. CE is equal to 1.5 meter. Therefore, for RA, the arm distance is 1 plus 1.5, 2.5 meter. And this triangular load, the resultant is acting at a distance of 1/3 of its base. So we are calculating the bending moment about the point E. The arm distance with respect to E is equal to 1.5 plus 1/3. 1/3 is 0.33 meter plus 1.5 meter, that is 1.88 meter. And what about the rectangular load? Rectangular load is 25 by EI into 1.5 meter. And what about the arm distance from E? It is 1.5 divided by 2, that is 0.75 meter. You can see the bending moment values at E. 1/A, common factor. This is the reaction, arm distance with respect to E, 2.5 minus the triangular load, 1/2 into 1 into 25, area of the triangle into the arm distance with respect to E, 1.833 minus area of rectangle, 1.5 into ordinate 25 of rectangle. Arm distance is 1.5 by 2. Upon simplification, we get this, and that is equal to 0.0037 meter is equal to 3.7 meter. This completes the calculation of deflection. I also request you to visit my website https://rgnsite.wordpress.com. There are about 500 university questions and answers covering all the various structural engineering subjects such as RCC design, steel design, structural engineering for diploma examination, strength of materials, structural analysis volume 1, structural analysis volume 2. It covers all the topics of structural analysis such as deflection calculation, moving loads, influence lines, moment distribution method, slope deflection method, strain energy method, matrix method, force method, flexibility method, arches, cables, suspension bridges, RCC design, beam design, column design, steel design, tension member, compression member,
Nearly 500 university questions and answers are addressed and uploaded in this website. Even the university question which we have discussed just now, it is also available in this website. All the 500 questions, including this one, is available for free download. The download is free. All the detailed questions and answers on various subjects of structural engineering is available in this website, and the download is free, including the one which we have discussed just now. Also, go through my videos posted in the YouTube. Name of the channel is RGM class. In the YouTube search engine, type RGM class. You will get the list of videos. Some of them are mine and some of them will be relevant. Choose one of the videos of RGM class, which will have the icon R, small r. You press that icon, then you will have the list of videos consisting only my videos and no, without any mix of other videos. So use RGM class in the search engine. You will have the list of videos. Choose one of the videos of RGM class. There you press the icon R, then you will get the complete list of my videos under RGM class without any mix of other videos. Thank you all. Thank you for your patient listening.